Hello guys, welcome to today's section of our studies on differentiation. We've previously learned about the basic rules of differentiation, and today we are going to continue with the advanced rules of differentiation. Specifically, we are going to deal with the product rules of differentiation. So, what is the meaning of the product rule? The product rule states that if u and v are both functions of x and we have y being equal to u times v, then the derivative of y with respect to x, because u is a function of x and v is also a function of x, so the derivative of y with respect to x is given by dy over dx equal to the u, which represent the first function, times dv over dx, which represent the derivative of v with respect to x, plus v, which represent the second function, times du dx, which also represent the derivative of u with respect to x. So in simple words, what do we have to say about this particular rule or property? So we have to say that first function, which is u, that is dy dx, equal to first function, the u, by the derivative of the second function, the dv over dx, plus second function, that is the v, times the derivative of the first function, that is du dx. So that is the rule of the product rule in differentiation. So in real life situation, if R is representing revenue and it is giving us R equal to price bracket time times quantity sold, which is also in the form of time. So, and both quantities are with respect to time, then the rate of change of the revenue with respect to time can be found by using the product rule. So let's continue with an example of the product rule. We have to differentiate y equal to x squared minus 3x plus 2. Then another function of x squared minus 2. These two functions are multiplying themselves. There is a product between these two functions. So how do we solve this particular question or find the derivative of this function using the product rule? So what we do is, the first one, we have to let u represent the first function, and when you differentiate u with respect to x, we are going to get du dx equal to 2x minus 3. So that is when you differentiate this function, it will be 2x minus 3. Then we also let v represent the second function, that is x squared minus 2. Then you find the derivative of v with respect to x. So our change in v, or dv divided by dx, is equal to 2x when you differentiate the function. So here we quote our formula or the rule for the product rule of differentiation, which states that dy over dx is equal to u dv over dx plus v du over dx. Maintain the first function, differentiate the second function, plus maintain the second function, differentiate the first function. So when we do that, we are just going to substitute. So dy dx will be equal to maintain the first function, which is u, then differentiate the second function, which is 2x, plus maintain the second function, which is v, times differentiate the first function, which will be 2x minus 3. The next step is for you to expand and simplify this particular expression. So the expansion will be dy dx equal to 2x times x squared will give us 2x cube. 2x times minus 3x will give us minus 6x squared. 2x times 2 will give us positive 4x. Then repeat the same thing for this particular function. 2x times x squared will be 2x cubed. 2x times minus 2 will give us minus 4. Then we have minus 3 times 3x squared give us minus 3x squared. Then minus 3 times minus to give us positive 6. The next thing is for you to simplify this particular expression to get your answer, which will be in the form of dy dx equal to 4x power 3 minus 9x squared plus 6. So this is an example of the product rule. Now, let's move to example 2, which is of the form y equal to square root of x multiplying x plus 1. So when you see this particular expression, we need to know that we are going to apply product rule to differentiate this function, because we have a function root x and another function x plus 1 multiplying. So here we let u equal to root of x. Then we find du over dx, which is equal to 1 divided by 2 root x. When you do that, we also let v equal to x plus 1. So when you find dv over dx, we differentiate this function, we are going to end up with an answer to be 1. That is change in v over change in x equal to 1. Then we quote the formula dy dx equal to u dv over dx plus v du over dx. Maintain the first function, differentiate the second function, plus maintain the second function, differentiate the first function. So when we do this, we are going to end up with dy dx equal to root x, which is the u. Then dv dx is 1, here is it, plus v, which is x plus 1. Then du dx is equal to 1 divided by 2 root x, here is it. Then the next thing is for us to simplify this particular expression to get our dy over dx equal to root of x plus 1 divided by 2 root x. So that is the solution for the example 2. Now, let's go to example 3, where we have to differentiate y equal to x cubed minus root m, then x cubed minus root m. So you can pause the video and try your hands on this one before you compare your answer with the solution. So let's go to the solution. We have to let u be x cubed minus square root of m. Remember, this square root of m is a constant to the expression. So here, when you differentiate du over dx, the answer is going to be 3x squared. The constant will be 0, because when you differentiate a constant, it will be 0. Then we also let v represent the next function, which seems the same. So here, our dv dx will also be 3x squared. We are going to repeat the same process by substituting this expression in the product rule formula, which will be of the form dy dx equal to maintain the u, differentiate the v, plus maintain the v, differentiate the u. Then we simplify the expression to have the answer dy dx equal to 3x squared bracket x cubed minus root m. So 2 times 3 will give us 6. So we are going to end up with 6x squared bracket x cubed minus root m. So these are examples of the product rule differentiation. So we have a practice section for you to try your hands on them. We are supposed to find the y dx of each of the following questions that we have here. Take your time, try this question, and send your feedback to us for us to go through it for you and help you understand this mathematical concept. So thank you for listening to us. Continue to follow this particular channel to receive the best of high school math education. Thank you.